Next question is, a window is in the shape of a rectangle surmounted by a semicircle. If the perimeter of the window is 20 feet, find the maximum area. So here we are having a rectangle on which there is a semicircle, right? So we'll consider the radius of the semicircle as r. So we'll get the length of the rectangle as 2r, and we'll consider the breadth of the rectangle as x. So let r be the radius of the semicircle. Let 2r be the length and x be the breadth of the rectangle. So given perimeter of window, which is equals to 20 feet. Now perimeter is all the boundaries, right, of the given window. So here the boundaries, if we see, it is the length and this two breadths and the perimeter of this semicircle, right? So we'll get 2r the length, 2x the breadth, right? And the semicircle perimeter will be pi r, which is equals to 20, right? Now we'll get the value of 2x from here, so we'll transpose this two terms there. So it is 2x is equals to 20 minus 2r minus pi r. This taken as equation 1. Now in the question it is asked to find the maximum area. So area of window A is equals to area of rectangle plus area of semicircle. So we know the formula is length into breadth, and so A is equals to length into breadth is 2r into x plus area of semicircle is given by the formula pi r square by 2. Now I'll write 2x together as we are having the value of 2x. So A is equals to 2x into r plus pi r square by 2. Substitute the value of 2x from 1. From 1 we'll get 20 minus 2r minus pi r into r plus pi r square by 2. So this can be written as A is equals to multiplying r inside. So it is 20r minus 2r square minus pi r square plus pi r square by 2. Now taking r square common in these three terms, so you'll get A is equals to 20r minus r square common, so it is 2 plus pi minus pi by 2. Taking the LCM, so it is 20r minus r square, 2 2's are 4, 4 plus 2 pi minus pi by 2. So this can be written as 20r minus r square, 4 plus pi by 2. 2 pi minus pi is pi by 2. Now we'll consider let f of r is equals to 20r minus r square, 4 plus pi by 2. Differentiate this function with respect to r, so we get f dash of r equals to 20 into r derivative will be 1 minus r square derivative will be 2r into 4 plus pi by 2. Cancelling out 2, so you will get f dash of r is equals to 20 minus r into 4 plus pi. Now differentiating this function again, so it is f double dash of r will be equal to constant derivative will be 0 minus r derivative will be 1 into 4 plus pi, which is equals to negative of 4 plus pi, which is less than 0. If the function derivative twice of r is less than 0, so we can say that f of r is maximum. And we know the other condition, for any maximum or minimum, the function f dash of r will be equal to 0. So for any maximum or minimum, f dash of r is equals to 0, which is 20 minus r into 4 plus pi equals to 0. So shifting this term there, so it is positive r into 4 plus pi is equals to 20. So r can be given as 20 by 4 plus pi. For area is maximum at r equal to 20 by 4 plus pi. So it is f of r equals to 20 into 20 minus 20 by 4 plus pi minus 20 into 20. It is r square, right? So it is 4 into 4 plus pi into 4 plus pi into 4 plus pi by 2. So here 2 ones, 2 tens, one factor gets cancelled. So it is f of r is equals to 20 into 20 is 400 by 4 plus pi minus 20 into 10 is 200 by 4 plus pi. Subtracting it, we get 200 by 4 plus pi square feet is the maximum area. Our next question is, a wire of length L is cut into two pairs which are bent respectively in the form of a square and a circle. What are the lengths of pieces of wire so that the sum of areas is least? So here there is one square and a circle, okay? There is a circle and there is a square. So a wire is there of length L, we don't know the length and we don't know the sides also of a square. So we'll consider it as x, and the radius of a circle will be taken as r. Let x be the side of a square and r be the radius of the circle. Given length of wire is equals to L. We know that length is nothing but all the boundaries of the square and the circumference of the circle, right? So it is nothing but the perimeter of both the shapes. So the perimeter of square is 4 into side, so it is 4x plus perimeter of circle is 2 pi r is equals to L. From here we'll get the value of x, so it is 4x is equals to L minus 2 pi r. Now x is equals to L minus 2 pi r by 4. Consider this as equation 1. In question it is given that the sum of their areas is least, that is minimum. Okay, so we have to find the areas. So let area A is equals to area of square plus area of circle. So we know area of square is side into side. The side is x, so it is x square plus area of circle is pi r square. Substitute the value of x here. So we'll get A is equals to L minus 2 pi r by 4 whole square plus pi r square. This can be written as 4 squares is 1 by 16. We can write outside, and L minus 2 pi r whole square plus pi r square. Now this function will consider as a function of r. Okay, let f of r is equals to 1 by 16 into L minus 2 pi r square plus pi r square. Differentiate with respect to r, so f dash of r is equals to 1 by 16 into, this is x power n derivative, x power n derivative is equals to n into x power n minus 1. This is dash. So it is 2 into the same factor L minus 2 pi r, right? This was not x, so derivative of it again. So L is constant derivative 0 minus 2 pi as it is, and r derivative will be 1 plus pi, r square derivative will be 2r. So here 2 ones and 2 8s, and here 2 ones and 2 twos are 4. So it is f dash of r is equals to, here there is minus, so minus pi by 4, minus pi by 4 into this factor L minus 2 pi r plus 2 pi r. Differentiate this again, we'll get f double dash of r is equals to, here minus pi by 4 as it is, L is a constant derivative 0 minus 2 pi into r derivative will be 1 plus 2 pi into r derivative will be 1. So this can be written as, this minus of minus becomes plus, so it is pi into 2 pi by 4 plus 2 pi. So it is 2 and 2 2's 4, so pi into pi is pi square by 2 plus 2 pi, which is a positive value and it is greater than 0. F double dash of r. We know that for any maximum or minimum value of the function, f dash of r will be equal to 0. So we'll equate f dash of r value to 0. So it is minus pi by 4 into L minus 2 pi r plus 2 pi r is equals to 0. Shifting this term there, so it is positive. So it is 2 pi r is equals to pi by 4 into L minus 2 pi r. Here pi gets cancelled. So this 2, sorry, so it is 2r into 1 by 4 into L minus 2 pi r. This 4 comes over here, so it is 8r is equals to L minus 2 pi r. Shifting this term to that side, so it is 2 pi r positive plus 8r is equals to L. Taking 2r common, we'll get pi plus 4 is equals to L. So 2r is equals to L by pi plus 4, and r is equals to L by 2 into pi plus 4. We got the value of r. Since we already got that, since f dash double dash of r is greater than 0, area is minimum where r is equal to L by 2 into pi plus 4. Now we have to get the values of the sides of the square and the radius of the cylinder. So length of pieces, first is the square. So we know the perimeter is 4 into x, which can be written as 4 into the value of x from the equation 1 is L minus 2 pi r by 4. This 4 get cancelled. Now we'll be remaining with L minus 2 pi r. Substitute the value of r. So it will be L minus 2 pi into L by 2 into pi plus 4. So here 2 gets cancelled. So it is L minus pi L by pi plus 4. Taking L common, so we'll get 1 minus pi by pi plus 4, which is taking the LCM now. So it is pi plus 4 minus pi by pi plus 4. So here positive and negative gets cancelled. So we'll be remaining with 4L by pi plus 4. This is the side of the square. And the next was the radius of the cylinder. Sorry, circle. Radius of the circle, which will be given by the formula of the perimeter 2 pi r. So here substitute the value of r here, so it is 2 pi into L by 2 into pi plus 4. The 2 gets cancelled, so it is pi L by pi plus 4. So we got the radius and the side of the square.